All right, let's go ahead and get started. Good morning, everyone. Thanks for joining us for our webinar, Performance Tuning for the Atlassian Toolset. We're recording this session and we'll submit a link to the recording over the next few days. Our next webinar is scheduled for June 3rd at 11 a.m. Central. This webinar is designed to teach you Jira workflow best practices. As you have questions, please be sure to provide them via the questions utility in the GoToWebinar control panel. We'll queue them up and answer them towards the end of the session. So on the phone today from Principio Consulting, we have Christopher Pepe. Christopher is a partner here at Principio Consulting. I'll be presenting today's webinar. My name is Shayla Sander. I'm a business development manager for Principio Consulting, and I'll be serving as your moderator. We've been Atlassian expert partners for over 6 years now and are one of 5 platinum enterprise experts in the country. Over 99% of our projects are Atlassian related, and we have hundreds of clients across the U.S., ranging in size from 20-person companies to Fortune 20 enterprises spanning many different industries. We help our clients with process-centric technology solutions that facilitate traditional business process management, IT service management based on ITIL, and software development life cycles. In the SDLC space, we're helping our clients transition from waterfall to agile, so whatever widgets you produce, we help improve the quality and throughput at the lowest cost. We support our clients in all facets of the Atlassian product suite and build methodologies and solutions across the entire product line. This includes solutions architecting and implementations, licensing, upgrades and maintenance, solutions, managed services, hosting, add-on development, and training. So with that, I'm going to go ahead and turn it over to Christopher Pepe, who's going to take us through today's webinar.
Thank you, Shayla. So in my typical fashion, I'm going to try to not take up too much of your time, but still tell you something interesting. So hopefully I succeed in that. We're looking at Atlassian performance tuning. So it's kind of 3 different areas that I wanted to highlight around this, and that being just general server metrics, the JVM itself, and then finally tools that are available to us via Atlassian. And then finally, we'll have time for questions at the end. I do expect to have some time, and I hope we do get some questions. This is becoming an increasingly popular topic. A lot of the projects that we're doing, at the very least, include some level of server assessment, especially with the introduction of the Atlassian Data Center suite of offerings for Jira, Confluence, and Stash. People are really growing Atlassian tools to much bigger instances than we've really seen in the past. And the Atlassian tools are sitting in a much more mission critical space for much bigger companies than they have in the past. So for both of these reasons, application performance has become really, really important. Both Atlassian and Principio have spent a lot of time trying to figure out what exactly are the metrics that matter the most. What are the things that we can look for when there is a problem, and what are the things that we can look for before there's a problem? So that's kind of what I wanted to talk about today. So starting off with just our basic server metrics. This is stuff that we have always been monitoring as long as there have been servers and applications and people paid attention to what was happening on those servers. We have always been monitoring the exact same basic server metrics. They're no less important today than they have been in the past, though. So one of the first things that we want to look at is CPU. The main thing that's going to constrain your CPU, or the main bottleneck that you're going to have around CPU utilization, is going to be concurrent users. There are obviously a bunch of other things that are going to affect that as well, but really it's, what are the things that are going to be computationally intensive? For the Atlassian applications, that really is concurrent users, a bunch of users doing stuff, spinning up a bunch of threads. You're going to be constrained not only by the number of concurrent users you have, but by the number of cores that the server is running, the number of threads that each of those cores can run. All of those are basically going to determine how many processes can be operating in parallel. The speed and all of those things of the processor are going to matter as well, but as long as you have reasonably modern servers, you're going to have fast enough CPUs. Most of you are probably running in a virtual environment. It's probably the most common scenario these days. So you have virtual CPUs that are being exposed. You have a lot of ability to control how those virtual CPUs are exposed to the virtual machine. And then, of course, we want to have some monitoring put onto those CPUs. So here the little graph that we have shows that we're not really using a whole lot of that CPU. We have a lot of room that we can grow into this. Memory is another place that is absolutely critical in the server. Because of the way that Java applications work, we allocate some amount of memory to the heap, and then when the application starts up, it just gobbles up all of that memory. And at the server level, we don't have a lot more visibility into what's happening beyond that. But there are other considerations to make as well. There are other applications that run on servers. Even if it's just a couple of other little daemons, they're going to need some amount of memory. Monitoring the memory usage, while it's more important at the JVM level, is still very important at the server level as well. For a lot of smaller organizations too, you're going to run your database server on the same machine as you're running your application server. So Jira and Postgres are running on the same database. I'm sorry, on the same server. So because of that, you want to consider how much memory you're going to need with your Atlassian application. As your utilization, as you onboard more people, as that grows, you want to make sure that you have enough room to be able to grow your heap to however big you think it's going to need to be, and still have enough memory left over so that the server can do the things that it needs to do. Now, we still have swap partitions laying around on servers. Historically, that was very important because RAM was very expensive. And we usually didn't have a lot of it. So swapping was a really effective way to extend the amount of memory that we had onto our physical disks, which were cheaper than our megabytes of RAM. While they still have use today, while they're still not they're pretty much the worst thing in the world, I guess. One of the biggest performance impacts you're ever going to see with an Atlassian application is once the server starts swapping. The worst thing that could ever happen is that your heap space, active heap space, starts swapping, or even inactive heap space. I guess your active wouldn't, but your heap space starts swapping. Once that happens, your performance is going to deteriorate rapidly. Memory is considerably cheaper, and we put ridiculous amounts of memory into servers these days, way more than, I don't know, Bill Gates or whoever said you never need more than 64K of RAM or whatever it was. And we're putting, I don't know, the physical machines that our virtual machines run on have hundreds of gigabytes of RAM. So memory is no longer a constraint. We don't really need to actually be able to swap. So one of the big recommendations we make is actually just disable swapping altogether. Don't allow it to happen. You're better off to have the out-of-memory killer running in your kernel, or just run out of memory, because once you start swapping, performance is going to fall off, and you're just going to, the server's going to fall over anyway. So those are really the considerations around physical memory on the server: is don't swap and just make sure that you have enough. The last major metric that we really care about on the server itself is the disk. Here's just a simple little snapshot of our var Atlassian directory. Obviously, the thing with disk space is you don't want to run out of it. You want to make sure you have plenty of headroom, just like with RAM. With disk space, even more so. RAM, you can a little bit more constrain. Applications shouldn't have memory leaks. They shouldn't just increase their memory space forever. They should generally kind of keep themselves constrained. But disk space is something that typically applications are just going to use up more and more and more of it. And it's much more common to use up more disk space than it is to have some process in there to free up unnecessary disk space. So for an example with Jira, out of the box, Jira is going to run XML backups twice a day, and it's going to create log files. Neither of those things roll over. So as long as Jira is running on your server, it's going to continue to use up more and more disk space, writing backups and writing logs. The higher your log level is, and the bigger your instance is, the more quickly that free space is going to be used up, because your backups are bigger and your logs are producing more log entries more rapidly. We had one client that had a very high level of logging. They had all of their SQL queries and all of the email that Jira was receiving and sending being logged to their files. And as a result, they were producing 1.5 gigabytes of log files per day. So this is a 40 gig disk, you got about a month of runtime before you chew up all of that disk space. Once you run out of disk space, obviously everything is going to stop working. Running out of memory and running out of disk space are two of the quickest ways to kill a server. So on our monitoring side, we want to make sure that all of the different volumes that are mounted to the server are all independently being monitored, and they all have alerts set on them, so that when they reach some particular threshold, we're alerted to that. We can go into the server and take corrective action before the disk fills up and before the application fails. It's also advisable to One, if you're worrying about performance, just disable the Jira XML backups altogether, because that's not really the best backup strategy to be using from a backup, disaster recovery, data recovery standpoint anyway. You really should be taking snapshots of the file system and of the database, or using some other strategy like that. So you should just disable the XML backups altogether, and you should take some sort of a strategy with your logs so that they don't just continue to grow and fill up the volume. You can put on log rotate or anything like that. And the other piece here on the right-hand side is that I/O utilization. I'll talk about that a little bit more when we get into the performance tuning that we do. But not only the disk space, the free disk space itself, but that disk access speed is actually critically important, especially for Jira. It's the most important for Jira, although it's important for all the other applications as well. Oh, well, then here we are. So with having all of these constraints that we know about, the best way to be proactive in it is to take a very strong monitoring and alerting stance. It's much better to be proactive, find out about potential problems before they actually get into that critical zone, and then get in there and correct them. This is another thing with server monitoring that we have known forever. You want to know what's going on in your servers, and you want to be alerted whenever things are getting bad, so you can get in there and take some sort of corrective action. Still, with the Atlassian applications, it's a really wide tech stack. There's a lot of different technologies. There's a lot of different areas for bottlenecks to sneak in there and cause performance issues. So the first thing that I wanted to talk about is Moneo, which is a technology that we've put together for assessing application servers at the server level, as well as at the JVM level, and then the individual Atlassian application level. This is a tool that we put together because we're doing so many of these assessments, and because there are a number of particular data points that we have identified as hotspots or problem areas. So we've started to automate that in a tool. We use this to find the root cause of problems for our clients. We also use it as an assessment tool to gauge, what am I trying to say? To gauge whether or not a particular set of application servers is going to perform at scale. So as usage continues to grow, is the server going to be able to keep up with the load? I think that I have a slide a little bit later. It's the sort of things that it's going to be looking into. But what it does is it allows us to very quickly look at a server, spit out a report that tells us these are known problems, these are known hotspots. You probably can't read this image too well. But if you can see that this particular instance of Jira is using Java 1.6, and it turns out that this version of Jira doesn't support 1.6. So that's a thing that we can very easily pick out automatically just by inspecting the server. We'll also do things like look at garbage collection, look into the Jira logs for errors and problems. There's an Atlassian tool called, it used to be called Hercules. I don't remember what they call it anymore. If they told me not to call it Hercules, I think. But it's that log scanning tool that's built into Jira. So this does a similar thing. It's going to look through all of your application logs for errors and try to compare them to known knowledge base articles. But we're also looking at things like disk access speed, database latency, a handful of other metrics that either we have decided are important or Atlassian has published that's important. The other piece that we use for real-time monitoring and alerting, as well as just to gain deeper insight into what's going on in our applications, is New Relic. New Relic is a cloud-based monitoring tool. We highly recommend it. We can help you implement that as well. If that's what you're interested in, that's what we use for all of our hosting monitoring. It allows us to look at pretty much every aspect of the server as well as the application itself, including transaction traces and things like that. So this gives us a unparalleled depth and visibility into what's actually happening in the running application in real time, and the ability to drill into historical events because it's tracking all of this information for some period of time. If we had an outage or we had an event that occurred at 5 p.m. last evening, we can go and very easily grab a half hour of data on either side of that event and look at what was going on and use that to start drilling into what caused this particular performance issue that we observed. The primary tool that we're recommending here is New Relic's APM, Application Performance Monitoring. They actually have a product called Insights, which I didn't really realize when I put this slide together, but I'm sure that was a little subliminal thing that I accidentally snuck in there. So Insights, from an APM standpoint, isn't giving us as much information, but is giving us a lot of really good in-depth information. There are plugins for all the different database servers that are out there, so you can monitor much more closely your database transactions, transaction times, look for long-running queries, and identify any of those sorts of problems. Similarly, at the server level and as well as the integration level, it'll automatically detect all of the external systems that you're integrated to. So for instance, if you go look at our Jira, our Jira application, it'll show us that Jira is also connected to Confluence and Bamboo and Stash, and it connects out to Google Docs, and it connects out to Salesforce and all of the other things that Jira integrates to. And that's all automatically discovered just by the transactions going across the server. So it's been a really exceptional tool for us from a monitoring standpoint. And then Moneo has been a really useful tool from us from an assessment standpoint to really get deep down into the weeds and look at very small minutia. Things like, well, this may seem obvious that the Java version isn't supported by that instance of Jira. It's something that's not immediately obvious when you just go look at a server. So having the ability to have a tool that automatically analyzes all of those things for us has made it a lot easier to pinpoint exactly where a root cause might be entering. An addition or an add-on to what New Relic is doing, really the reason that we started using New Relic was to get this insight into the JVM. So like I said, with the heap especially, but really a lot of what's happening in the JVM is kind of clouded in mystery, and you don't really know what's happening. You really need some sort of a JVM monitoring tool to be able to understand what's happening inside that virtual machine and really pinpoint problems. It's very, very rare, or it's at least very low-hanging fruit that something goes wrong in Jira or Confluence or Stash, and you just pop over to the log and you look in it, and it's like, oh, this is, can't connect to mail server, and you're like, oh, that's pretty obvious. Good, I can go fix that. The vast majority of the performance problems that you're going to have are going to not put any error messages in the logs, or if they do, they're going to be red herrings. They'll be inconsistent. It'll be an error about this particular user not having permission, and then this project doesn't exist and some other thing, and you'll always get a different error every single time. So you can see that something is wrong in the Jira logs, but you can't tell what it is really until you actually dive down into the JVM and try to figure out what's going and look at the threads and how they're operating. You're not going to have a really good idea in a lot of cases what's actually happening. One of the easiest things that we get out of New Relic and JVM monitoring. So there's also Java Melody. If you can't put any of your data in the cloud, or you're worried about any of those sort of things, there's Java Melody and a bunch of other tools that you can run locally as well. All of those will still give you. They're not as nicely polished of a tool as New Relic is, in our opinion, but we still work with them quite a bit. And Java Melody does give you quite a bit of good information, which I'll talk about on the next slide. But two of your goals for getting the highest performance Atlassian application, this is really, I guess, just any Java application, but we're here to talk about Atlassian applications. But what you really want to do is minimize your heap size. So what you want is the smallest heap possible without running out of memory. So really what the ideal situation is, which you would never do in a production environment, but what you really should do is take your maximum heap size and just keep decreasing it and decreasing it and decreasing it until your application runs out of memory. But as soon as you get that out of memory, as soon as a Java application runs out of memory and there's nothing left in the heap, it just falls over, and now it's crashed, and now nobody can use it. So you'd never want to do that in your production environment. But really, ultimately, that's the goal that you're trying to get to is what's the smallest possible heap that I could have, so that all of the different things that happen on Monday morning, everybody comes in, they load up their Agile boards, and they're doing their stand-up meetings, and that uses up tons of memory. And then in the middle of the night, we're running backups because we're using the XML backups, and that has this big CPU and memory spike. All of those places where all of those maximum memory events occur, you want to know what's the smallest amount of memory that we can have and still not ever outrun that. Java heaps are a little bit they're a little bit sneaky in that you kind of looking at this graph, it would look like our maximum heap usage is about maybe 1250 megabytes, 1.2 gigs, somewhere around in there. But it might actually be a lot closer to 1 gigabyte or even 750 megabytes. When the heap space is there, the application tends to use it, and it tends to use it less efficiently than when the heap space is not there. That's actually part of the problem. That's why you want that minimum heap size, and so that the memory usage is much more efficient. So you can't necessarily just look at this graph and say, okay, well, cool, we can just drop it down to 1250 or 1300 to be safe, and we'll never need to worry about it again. There's a little bit more to it than that. But having this JVM memory graph does give you a lot more insight, and you can see where the peaks are and you can see where the spikes are. You can understand when are those events occurring that cause us to use a lot more memory, and does it look like we have way too much heap size. The next thing that you really want to consider with your heap is that you want to do whatever you can do to minimize the amount of stress on your garbage collector. We'll talk about garbage collecting next. But garbage collection turns out to be a very, very critical process in JVM memory management. Without it, the JVM would just run out of memory. And with it, you have the potential to cause a lot of performance problems. So the way that garbage collection works is every once in a while the garbage collector goes through the heap and it looks for old stuff that's no longer used. And when it finds those old pieces of memory, it frees them up and puts them back into the heap, so now they're available and ready to be used again. The way that it does that is it stops time. And then it goes and it does all that garbage collection, and then it starts time again. That's more or less what the operation looks like. So for Jira is ticking along, and the seconds are ticking away, and it just continues on with its life. What it doesn't realize is somewhere in the middle there, the garbage collector came in, paused it, did a bunch of stuff, and then started time again. So there's actually this little temporal gap in there that Jira wasn't actually awake, but time was passing. But it's unaware of that. It doesn't know that it happened. While that sleeping time is occurring, while time is stopped for Jira, it's not responding to requests, it's not processing anything, it's not doing anything. So if that gap gets to be too big, then users start to notice it. So if the garbage collector comes in, takes 100 milliseconds, and then starts time again, that's potentially going to show, that's potentially not going to show. If the garbage collector comes in and stops time for 1, 2, 3, 4, 5 seconds, people are going to notice that. That's going to cause huge performance issues. And it doesn't sound like, Jira has like a 1 second page load on an optimal kind of system. So a 1 second delay doesn't sound like it's that big of a deal, but it actually ripples through the system and creates much bigger delays, creates a lot more gaps, and it stops a lot of things from working efficiently. So the garbage collector taking a lot of time to collect garbage is one of the biggest things that will cause really bad performance issues. One of the easiest ways to reduce the stress on the garbage collector is to set your heap size minimum and maximum to be the same. So here in this example, this is from the setenv.shell file, which anyone that's installed Jira and had to deal with any of these things, you should recognize these memory settings. In your Java ops, this is going to set the XMX and XMS Java options. So here I have the heap set to a maximum of 1 gigabyte and a minimum of 1 gigabyte. The out of the box is like 768 and 512 or something like that. So what that means is that Java knows that it has a maximum heap of 700. Well, let's just go with 1 gig and 2 gigs. So I don't have to keep throwing out lots of numbers. So it has a maximum heap of 2 gigabytes, but it has a minimum heap of 1 gigabyte. So it's always going to try to get the amount of heap space that's committed down to that 1 gigabyte level. So you're basically always going to be fighting. The garbage collector is going to run a lot because it's always trying to get the memory level down to that 1 gigabyte, even though it could grow up to 2 gigabytes, and we're okay with that. So a really simple way, and one of the standard recommendations to minimize that stress on the garbage collector is make the minimum and the maximum the same amount. That way, the garbage collector isn't trying to attain some goal that it may never be able to attain. That's really where you start to see those performance issues, is that if what we need is 1.5 gigabytes of heap space, but our minimum is set to 1 gigabyte, then it's always going to be trying to fight to get below that 1.5 gigabyte level and get down to 1 gigabyte, and it's never going to be able to get there because it needs more space than that. And since I've been talking about garbage collection for the last like 5-10 minutes, let's actually just move to the garbage collection slide. I've told you a lot so far about why garbage collection is important, some of the strategies that we can use to minimize the stress on the garbage collector, even what garbage collection is. None of those really necessarily help you improve your situation all that much, though. If what you know is that you need to do some GC tuning and you don't really know anything about that. There's a lot of information out on the internet about GC tuning. Really, unless you can empirically demonstrate that you are having garbage collection problems, you shouldn't attempt to do any GC tuning. Or, and if you're a Tomcat Java application expert, then knock yourself out. But for the standard admin who doesn't really necessarily know a lot about garbage collection or tuning Java applications, you can do more harm than good by fiddling around with your garbage collection settings. So there's a handful of different garbage collecting strategies or garbage collectors that are available to you. GC Serial is one of them. Not necessarily the best choice, though. Depending on what version of Jira you're using, there's actually different recommended garbage collectors to be using. So you want to make sure that you're using the appropriate garbage collector for your version of Java and your version of Jira. If you're going to go look into tuning, before you do too much of that, the first thing you want to do is go turn on logging. So it's in setenv or one of those other files. There's an option there to turn on garbage collection logging. Then it'll actually start producing garbage collection logs, and you can take those logs, look at what the garbage collector is doing, and start to try to understand that. So this graph that's being shown here is showing garbage collection as it's occurring. It's a little bit difficult to read just like this. I'm not going to bother going into the graph itself, but you're going to get a graph that looks more or less like that. And then one of the things that I mentioned way in the beginning when we were first talking about memory is swapping. So the worst thing that you can possibly have happen is that you swap memory to disk. That memory exists in your Java heap, and some of the pages that are in the memory that's been swapped to disk need to be cleaned by the garbage collector. This goes back to the fact that I said that the garbage collector stops time, and however long that gap is, the longer that gap is, that time has been stopped for Jira or for the application, that's going to more and more significantly impact performance. So if you have a situation where you have part of your heap has been swapped to disk, the garbage collector wants to go grab that stuff and free it, and time is now stopped for Jira, it's going to take a lot longer to go to the disk, read all that stuff off the disk, get it back into memory, figure out what you're going to do with the garbage collection, collect all that garbage, throw out what you don't want, update your hidden space, do all of those things, and then move on with things, as opposed to just pull it out of active memory. Pulling it out of active memory is much, much faster than pulling it off of the disk. Even if you have super high performant disks, you don't ever want to swap any part of your heap, and that's a very real danger. That's why we recommend just disabling swapping altogether and just not allowing swapping to occur. All right, I think I've beat up garbage collection enough. There are a ton of Atlassian tools that are already available for you. Most of these really came out of the move to data center. So as Atlassian was preparing for Jira Data Center, they started doing a lot of performance testing on Jira. They started gathering a lot of metrics. They started talking to a lot of their clients, because as I'm sure most of you are aware, our historic approach to Jira performance tuning and our historical tools were kind of cover your eyes and throw a dart and see if that helped, and if that didn't help, then try something else. So over the last few years, Atlassian and Precipio have both spent a lot of time trying to really gather evidence and be able to make evidence-based decisions on what we want to change, why we want to change it, and does it create a measurable difference. So we really want to start with that root cause and then figure out what can we do to correct things from there. So the nice thing is, as an output for that, especially for Jira, there's a lot of really great tools that Atlassian wrote that are available to you today. We use all of them in our assessing, but they're also freely available to you. We look at other things as well, and if you want to do an exhaustive assessment of your server, we're certainly happy to help you with that. But a handful of tools that are out there right now that you should definitely go check out are the disk access speed test. So if you just put in Jira disk access speed, it'll pop right up. It'll be the top of your search. And what it's going to do is run a disk access speed test on your application server as if it was Jira or as if it was a Java application, because it turns out that sitting in a Linux terminal and operating or writing a Python script that opens a file, writes some data to it, closes the file, that's actually different than if a Java application does it. The way that Java sees your disk through the JVM is different than anything else. So Atlassian wrote a Java application that accesses the disk, and you want to point it to your cache directory because the cache is the single most important thing. The disk access speed to your attachments is considerably less important because attachments are really large and we expect them to take a long time to load anyway. And the latency of waking up the disk and reading data from it is very small compared to the read time required to read a multi-megabyte file. But the index, which is where everything that Jira renders comes from. So when you click on your issues menu and it shows you your recent issues, you click on the projects menu, it shows you your recent projects, or even when you load an issue and all the different pieces of information that pop up in there show up, all that comes out of the index. Jira does that so that it doesn't have to go to the database because reading from the database is slower than reading from the index most of the time. But if your disks are slow, for a number of reasons, then reading from the index actually becomes slower than reading from the database, and now you have a performance issue. So the disk access speed test will go and actually test your disk just as if it was Jira or just as if it was an Atlassian application and give you an indication of how fast your disks are. So here underneath open, for instance, if it's, these are all nanoseconds. So it's less than 40,000 nanoseconds. That's considered an excellent file open time. All the way up to bad. If it's greater than 150,000 nanoseconds, then it's taken too long to open files and you're going to have really bad performance. So again, while this is the most important and the most critical for your Jira indexes, it's relevant and applicable to all of the applications. So for instance, a thing that we have seen with clients a handful of times is that they're using some virtualization technology and they have their VM set up, and when you go onto the server and you look at it and you look at the CPU and you look at the disk and you look at all this stuff, everything looks just fine because what the virtual machine template describes the machine as, everything looks great and there's no problems with anything. But because of a misconfiguration in the virtualization layer, the virtual disk hooking up to the actual physical disk out on the SAN somewhere or wherever it is was causing huge latencies. So we would see open and read times of 1 million nanoseconds as opposed to less than 40,000. That was a way that while the disk access speed didn't directly tell us there's a problem in the mapping of the physical hardware to the virtualization, that indicated that your disk access speed is a problem. This is why you're having performance issues. And that led us to the actual root cause, which we were able to resolve. So again, even though this is designed for Jira indexes, it's a very valuable tool just as a general assessment tool for the health of your server. Another one that's available, unfortunately only for Jira, is a database latency test. So the main thing that we know about your database latency is that round trip needs to be less than 20 milliseconds. So if you start to do all of the math and all of the different parts of the technology, Jira needs to know that it needs to talk to the database, so that takes some amount of time. It needs to make the network request, so it's going to take some number of milliseconds to actually route through the network to get to the database server. Then it's going to take ideally less than 20 milliseconds for the database to process that request, gather up the results, and pass them back. Then whatever your transit time on the network was is going to take that amount of time to get back as well. So even if it's 20 milliseconds at the database, it could be 40 milliseconds, 100 milliseconds, 200 milliseconds, because of all the other different layers of technology in between before that database response actually gets back to the processor. And then we have to run through all of these JavaScript and dress it up and stuff in the index and put things over here. And that's really why we get those 1+ second page load times. There's a lot of different pieces of technology that all this data is flowing through to get back to the user in Jira and get that really nice user experience that's pretty and easy to use and easy to understand. So something that's been critically important is that database latency latency is as small as possible. Now, if you're running your database locally, that means that you probably have a sub 20 millisecond response time because you're talking to the database over your loopback interface. Um, if you're going to run your database server somewhere else, which is most likely the case if you're going to be in a situation where you're having performance issues and you have a big enough instance, then your database server is probably somewhere else. In that particular case, the strategy that you really want to employ is to have multiple network interfaces so that your HTTP traffic, your users, can come in over one network interface. Then you have an entirely separate dedicated interface to that database connection. Or it could be database and multicast and all the other backend technologies. Really ideally you put multicast in its own as well, but that's getting into different areas that we don't necessarily need to go into. But you want to make sure that the routing tables between your application server and your database server are such that it's as short of a network transit as possible, and that the database is performant enough to service these sub 20 millisecond responses. Really minimizing that round trip time that Jira needs to go get data out of the database is going to be very critical. Other resources that are available to you, a lot of them involve just reading. The Atlassian documentation, there is a ton of information out there. So between the Atlassian documentation on confluence.atlassian.com, help that you can get from other experts, or, and by other experts in this case, I'm actually referring to just the community at large, the user base that's out there. There's answers.atlassian.com. So a bunch of Atlassian big E experts like Precipio spend a lot of time on answers, but a lot of just normal users spend a lot of time there too. The Atlassian world has a very big and very healthy community around the ecosystem that they have built. There's a lot of people that are out there just trying to help each other out. And then Google does a great job of indexing all of those sites. A lot of the times the problems that we're looking for lead us to an answers article or an answers.atlassian.com question, which points us to a knowledge base article that helps understand what the root cause of what we're seeing is. There's a lot of really great information that's already out there in Atlassian's knowledge base, in answers. All of you should have valid licenses to your product, so you all have access to Atlassian support as well. If all of those things aren't enough, you can always have a managed services contract with Precipio as well. We can dive a lot deeper into your systems than Atlassian can, and we can give you a lot more of that kind of boots on the ground extension of your team. So we went through server metrics kind of pretty quickly just because it's a pretty old topic. It's been around for a while. If you're already a sysadmin kind of in this role, you should already know that you should be monitoring CPU and memory and disk space and a handful of other metrics on the server itself. But those are all still really critically important. So you definitely have to be monitoring those things, and they can cause performance issues. I talked kind of at length about the JVM. A lot of it really revolved around managing the heap, because that's where we really see the largest amount of problems. But having visibility into the JVM and being able to trace transactions and things like that is also critically important when you have those little ghosts floating around. You can't figure out why your system isn't performing correctly. New Relic is a great option if you're going to look at JVM monitoring. And then I talked about the Atlassian tools that are available, that are already out there. I only highlighted a couple of them. There's actually a bunch of other ones, and if you go out there and look at performance tuning for Atlassian, there's a bunch of really great articles around that. And then obviously you can always reach out to Precipio as well, and we're happy to talk to you about all of these topics and help you figure out either why you're having performance issues or if your servers are going to scale to the load that you're expecting as you onboard new users. So I haven't been paying attention to the questions, but hopefully we have a few that have come through. If we haven't, we can just give you this time back, but I'll hand it over to Shayla and see if we have anything.
Sure, yeah, thanks, Chris. We do have a couple of questions. So the first one, disk access slide. CPU performance can also have an effect on disk access, true?
Yeah, it definitely can, because if the server is very busy, it's not going to have the cycles necessary to go and actually access the disk. In that particular case, you're monitoring, whatever you're using to monitor your CPU should show you that the CPU is pegged. So certainly if the result came back, the disk access is really poor, you'd want to look at all the other metrics on the server and see, is there a reason that's obvious for why this disk access speed is so poor? But yeah, the CPU being pegged definitely would affect that.
Okay. And then there's a second part to this question as well. IO weight, database response, etc., can also play a factor in disk access, as we have seen. What all comes into play with this?
So it was I/O utilization,
Database
CPU.
response.
They can affect disk access speed.
Yes.
Yeah, that's also true as well. So really the Atlassian talks about ecosystems so much. I hate to just keep throwing the word ecosystem into everything, but your server really is this kind of little environment of all of these interacting parts. I used to be an embedded systems engineer, so I probably know too much about the inner workings of computers. Um, but really why we started diving much more deeply into what is it that causes poor performance in Atlassian applications is exactly because of these problems. People would say, it doesn't work, and there would be no obvious answer. There's nothing in the logs. You look at the general server metrics and things they kind of look okay. Nothing really looks that bad at this particular point in time. Typically with these performance issues, we're having a really bad, like Jira's really slow right now, but then by the time someone goes and looks at it, it's running fine again. That was really why we started to dive down into these performance assessments and try to figure out what is it that's really going on. You have a lot of different moving parts, and especially because most people are running these applications in some virtual layer, you have the virtual machine itself, you have the virtualization technology, you have the hypervisor that runs on. That usually plugs into some other set of back-end applications. I'm sorry, not applications, but devices, which all have their own redundancies built into them, and they have very complex wiring diagrams. And all of the software and all of the hardware in that whole chain, all the way back to the little magnetic head reading the actual physical disk, all of those things are potentially problems, and any one of those can potentially be the bottleneck that's ultimately manifesting itself as this poor performance. Ferreting out those can be very difficult sometimes, especially when it is something like, the I don't know, one of the fabrics failed in a back-end piece of hardware, and that's causing data to be routed over a different mesh than it used to, and now that manifests itself in some way in the next physical layer, which then eventually shows up in the virtual layer, which then ends up in Tomcat and finally pops up in Jira. So it can be really hard to ferret out some of those things. Something as simple as a bad network cable can manifest itself as intermittent slowness and poor performance in Jira. And it can take a lot of debugging and a lot of really hard work to figure out that it's this particular network cable that is bad, and it's only some of the time the traffic gets actually routed through that physical wire. But all of the things that are happening on the server as well as the physical back end are all potentially suspect. Really the place that I have come to is that whenever we have a problem that's being assessed, I start from the smallest basic block and I make no assumptions. I don't assume that anything works correctly, and we go by piece and validate that each piece is working before we move up to the next layer. It's just been too many times that something that seems like it couldn't possibly be the problem is actually the problem. It's just that all the red herrings were pointing off in different directions, so it masked the fact that this thing that we assumed was correct is actually wrong.
Okay, thanks. Next question. Is there an assessment service offering? Do you use Moneo for that?
We do. So yes to both of those things. Depending on what you're looking to do, I'm sure there's different packages and options and things like that. And Shayla would love to talk to you about the specifics of that. I mostly sit on the actual implementation end of those assessments. So usually the way that the engagement works is we show up and you have one or more servers that you want to look at. If you're having a performance issue, that's a very different scenario than if you're just looking to validate that your infrastructure is going to scale well. So in the case of, say, you want to go from standalone Jira to data center, and you just want to make sure to validate that the hardware stack and the software stack that you're going to run on it are all going to be performant. So that'll be a smooth transition. We'll come in, we run Moneo against it, that spits out a report. A senior network engineer or senior engineer goes through it, does all of the analysis, and decides based on the outputs that we get what additional information we should go gather, what conclusions we can draw from that, and kind of finalizes the report that you would ultimately get. Any problems that we discover, we try to work with you, depending on how long the engagement is. If there's actually time in it, then we work with you to correct those things and then kind of redo the assessment again at the end to show that those issues were corrected. While we do use Moneo and all of that, it ends up just being the kind of the bit of technology that we have built to help us do that assessment work a little bit more quickly.
All right, thanks. Next question. Do you find new Relic instrumentation causes any performance impact or problems for the applications?
That's a really good question. That was one of my biggest concerns when we first started using it, because you're actually installing a plugin into your application server. It's capturing all of your transaction traces, shipping all of that data off. I can't really say that we've actually noticed a performance impact by the fact that we have New Relic there. I'm kind of curious to do a little bit of a deeper dive and a little bit more of an analytic look at trying to figure out, there's some percentage of performance loss. There has to be, because it's doing a bunch of stuff that we didn't used to do. But from a, anecdotally application performance, it really hasn't made an impact for us at all. So the impact it's having is a couple percent or something. It's pretty small. The New Relic team has done a really great job with their product. I know there's a handful of other products out there that do similar things. I don't have nearly as much experience with them, but the exposure that I've had to the New Relic engineering team and the experience that we've had with their product has been great. It seems like they've done a great job in implementing it.
All right, thanks. And then last one, it's not really a question, more of a comment. So thanks for that, Mark, but cannot get a connection to the underlying connection pool is a red herring a vast majority of the time for I/O issues on the application or database server. Do you agree?
That is a gem right there. Yeah, I actually forgot to mention it. I wanted to go back, because this was for Atlassian application tuning. I know I talked a lot about Jira. I was trying not to do that, but Jira actually has a couple of graphs that are built into it, and one of those is the connection pooling. But yeah, we've seen that exact same thing in Confluence as well, and there's a lot of red herrings. The error messages that you get, you can't trust them outright. You have to go through and do that root cause analysis and keep drilling down until you find the thing that's actually causing your problem. And I/O is definitely one of those things that throws out a lot of false leads.
Great.
It's cool. It sounds like we have a good technical bunch on the call today. I'm sure you've gone and suffered through a handful of these, just like we have. These are probably the hardest thing to do in the Atlassian world. Most of the stuff is pretty straightforward. This performance assessing, especially once you have degraded performance, is just probably the hardest thing that we've run into in the Atlassian world.
Well, great. Thanks a lot, Chris. That's it for questions. I want to take this time to thank everybody that joined us for taking time out of their schedule to watch our webinar today. Just a reminder, our next webinar is going to be June 3rd at 11 a.m. Central, Jira Workflow Best Practices. If you have any outstanding questions after the webinar, you can send those in to sales@precipio.com, and we'd be happy to answer them for you. Thanks a lot and have a great day.